All right, so we're gonna be live in a sec. So we are on. So have to catch up. Right. Okay. Here we are. So welcome back, people. So we're gonna continue what we were doing day before yesterday, and we were trying to get the calling to work, or rather, we got the bot to work. We didn't get function calling to work. So today we're gonna do that. We're gonna start working on function calling and see how we can use our chatbot to call to an API using the OpenAI's function calling endpoints. So before that, let's understand what function calling is and how it works. So let me go to OpenAI function calling, right? So favorite documentation, too bright. If I can focus it to get into the dark mode, a sec. Right, it is in dark mode, yeah, but I think OpenAI have anyway. So you got to bear with me on this. So it is bright. So the thing between chat completions and function calling is that function calling can choose to output a JSON containing arguments to the kind of functions you want to call. And so just to give a little bit of a history. So earlier there was this completions API, and this was just GPT 3.5 or even GPT-3, and it's basically given a prompt, it kind of finishes the prompt, right? So that was that. It was not. It was not trying to do this. Like for example, if you say, "I went to college, at Boston University. After getting my degree, I decided to make a change," and the rest of it was basically what the completion was. So uh, it was not question and answering. It was you could have question and answering as well, but it was more like, oh, you continue making the predictions on these tokens that are going to come next. uh, Now chat completion API basically is I guess it goes to a different model, but different class of model, which has RLHF, reinforcement learning with human feedback. So where you're giving it instructions in terms of questions, and it's giving the answers, and you go back and forth on this. Now, function calling is yet another sort of like a fine tuning, I guess, that they did do on their existing question answer model. Yeah, I don't know if it's going to be one model, multiple models, whatever be it. Um, but most likely it is that the same model which is also doing function calling, or it kind of like outputs as a last token that it needs to call a function, and then they probably send it off to another model which probably decides which function to call with what parameters given the context. But let's quickly look at the documentation and see how we can try to use it in our case. Um, so let's see. Uh, in an API call, you describe the functions to GPT 3.5 Turbo 0613, and yeah, this is the 0613 is basically what we needed. And I think it's like 0613 stands for like June 13th. They release this model and they say it's good for 3 months, or whenever it is when they're going to retire it. And so once you choose the functions and you describe the functions to these models and have the model intelligently output a JSON object containing arguments to call this function. The chat completions API does not call the function. Instead, the model generates JSON that you can then use to call the function code, which is cool, right? I mean, they don't, which is in a way is good because it also lets us control the security aspects of it so that the call happens from our server and it's not something that originates from OpenAI itself. So the latest model, GPT 3.5 Turbo 0613 and GPT 4 0613, have both been fine-tuned to both detect when a function should be called, depending on the input, to respond with JSON that adheres to the function segment. With this capability also comes potential risks. Strongly recommend building and user confirmation flows before taking actions that impact the world on behalf of the users, like sending an email, posting something online, making a etc. Okay, makes sense. Also launch a nuclear device or whatever. Why would you want to connect a model to that? But yeah, anyway. So the idea is that, okay, be careful about what it can suggest that you do with your API. Under the hood, functions are injected in the system message syntax the model has been trained on. This means that the functions count against model's context limit and are built as input. If running into context limits, we suggest limiting the number of functions or the length of the documentation you provide for function parameters. Okay, kind of makes sense. So I guess, so how do we describe the function? Function calling allows you to more reliably get structured data back from the model. For example, you can create chatbots that answer questions like calling to external APIs like ChatGPT plugins, like define functions like send email or get current weather and so on and so forth. Convert natural language into API calls, like who are my top customers, to get customers, win revenue int, created before string limit int, and call your internal API. So, okay, let's see. Or extract structured data from text. Like define a function called extract data and it gives name, string, birthday, or something like that. Or SQL query colon string, and much more. The basic sequence of steps for function calling are as follows. Call the model with user query and set the function defined in the function's parameter. Okay, we'll look at that. Um, the model can choose to call a function. If so, the content will be stringified JSON object adhering to your custom scheme. So the model may generate invalid JSON or hallucinate parameters. This is going to be fun. When you thought, okay, your API, your front end should give you valid data and validation and all that. Now, uh, your AI model can give you wrong data. So I guess we have to level up our validation game here. Parse the string into JSON into your code and call your function provided arguments if they exist. Call the model again by appending the function response as a new message and let the model summarize the results back to the user. Awesome. So you can see the steps in this action. So let's see. Uh, this are the messages. Like for example, we'll get current weather. I guess this is the dummy function that they're going to call. So the idea is that you say let's see where the chat completion falls. So they just pass in messages. Okay, let's look at messages. Role, user, content. What's the weather like in Boston? Okay. Um, and we also pass in functions to it, and we are giving one function which is get current weather, and we give the description to get the weather in a given location. And then I guess this is just JSON schema. The parameters type is object, properties we say location is type string, description the city and state. Example San Francisco, California. And we say, and then it has another property called unit, and that's for type string. It's an enum of Celsius or Fahrenheit. And then they also say at the, I mean, you definitely need to pass in location. And then once you call this function with chat completion dot create this function, and then you call and you set the okay, call is auto, which is fine. If functions are defined, I guess it's going to call that, but will be auto is the default, but will be explicit. Okay, and then it gives you back responses, and uh, if the response uh, if the response messages function call, this is we'll need to look at the API for this as to what the thing is because using Python. But um, if the response message is function call, then they basically declare a map which is like the available functions. The current weather is this. Um, you get the function name, you get the, I mean, you then map it onto the actual function that's there. You get the arguments, and then they basically say, okay, one of these arguments should be location, one of these arguments should be response. Um, they call it. I mean, they don't quite check if they could have as well called it, because anyway they're anyway hard coding the rest of it. Anyway, so and then you do a messages dot append on the response message. Okay, wait. Oh, okay. So the messages is what we set up earlier, so which is essentially just this. And so whatever OpenAI returns as a function call, we add it to the message. I mean, that's what we do as well in our bot response. So yeah, makes sense. We add that, and then we also add role is function. So instead of user or assistant or system, we say role is function here, and we say the name of the function is the function name, and we also set the response for the function. So which is so that is I jumped. Sorry, we lost the context here. It was so you have the role function, the name of the function, the content is the response, and then uh, we make another call to chat completion. Yeah, I mean, because the reason is not stop, so you got to do it until the reason is stop, and then you do this. So let's look at it. So let us see. Let's go to the API reference, and let's try to map this onto our chat completion object. So in the chat completion object, you have this choices, and you have the messages, um, and in the messages you have the function role. Um, I think we also have the stopping right here, finish reason. So finish reason part of um, choices. Is it a part of No, I think the finished reason is directly as a part of the chat completion, and here is where it is. So let's try to understand this. Create chat completion. We haven't looked at some of the stuff, but yeah, we'll look at what these means. But um, so the returns a chat completion object that are string chunks. Okay. Okay. Stop is Okay, the finished reason of the model may be stop generating tokens. This will be stop if the model hit a natural stop point provided by the stop sequence. Length is there, or it reached function call, and this is what we want. So we want to basically handle this case where it's a function call and then do this. So let's go back to our bot and see what it is. So here uh, we do this for a step, and we actually build this request in a step and execute it. Here we don't look at the stopping reason. So here essentially we'll be looking at the um, stopping reason uh, choices though. Uh, this is an option. So if it is some choice, so let's see. Choice start message. Um, oh, there's this finish reason. So if this finish reason basically is a sum of function calling, essentially we got to do something here. But before that, let's also look at the function call object. So it says function call is basically a string controls how the model responds to function calls. Oh, the request body. So okay, you need to give um, you need to give this functions, so name, description, and parameters. Parameters is an object, and that's a JSON schema reference. So this is what we're going to pass in as parameters to the function. So, so this is an array, right? So you basically say, multiple functions be sense. So let's try doing this. So I also set up um, a, a simple API. It has a lot of bugs, but it should be good enough for our case. So I set up this booking is repo, and this is in TypeScript and Node. So look at as. Oh, by the way, I use bun for this. So you see here it's bun, but it's a pretty simple Fastify server. Uh, I have JWT based authentication for I think creating a booking. Everything else is public. So let's look at some of the. It also uses Prisma. The model is pretty simple. Uh, so you have a bunch of locations. Uh, for each location, you can have multiple facilities, um, and the facilities can essentially have number of seats. Maybe you can also track whether it has like a TV in it, a projector in it, or a whiteboard in it, and things like that. And then I also have a user. Every facility is managed by a user, and then I mean, you also have bookings for a given user for a given start time to end time. Um the model is pretty simple. Let's see how we can use this. Um, so, and of course, everything is on Postgres. So let's see. Um, hyphen. I have the dev. I have this table here. So all these tables are there. Um, so I have a few locations set up. I also have a couple of uh, facilities or venues set up, and I have some booking set up. Couple of bookings. That's there. I also have the API. So let's run this. And sorry, start the server. Uh, yeah, I see this happening. I don't know why though, but it says the failed to listen on the port. It's a new, uh, but works because maybe because it's on port at the host. This or let me put 0000. Let's see if that works. So that way it's only starting on IP4. Yeah, that seems to solve the problem. Anyway, so now let's try making some requests onto this. HTTP host 1000 slash locations should work. Um, PIV one host slash API slash right. So similarly, we have uh, locations one slash facilities, and we see that there are two of those facilities that are there in location one, and we can also get bookings. Oh, bookings requires a JWT token. And the way I have set up JWT token is I um, I look for is I look for the user ID within the request, and essentially we try to map it from that. So let's create a JWT token for the booking. I just like to go to jwt.io and then stick in a token here. So instead of sub, I'm just going to say user ID going to be 1, and I need to have the secret. So in VRC here, yeah, super secret. So this is my JWT token. I'm going to take my JWT token and put this in the header. Uh, I'll just put the so and I'll whole thing in quotes so that the space is taken care of. So now it gives me the booking actually. So this is pretty much what we need. I think on second thoughts, I'm just going to paste this because we're going to copy other stuff and we're going to test it and it may not work then. All right, so you have the booking for the user, and that works, and so on and so forth. And he has booked facility ID1, user ID1, all that stuff. So we're going to describe these APIs, and we're going to use them. So let us go back to let's go back to our prompt and then write a good prompt for this. So we'll say that we'll create a venue booking venue bot. We'll call it. Keep it simple. A wrap uh, or full customer book facility use the API below to uh, data or access details that not uh, or let's even give it a little person. We'll say Vivery is a company that provides facilities for customers to book. Uh, our bot, or you can say uh, is has location different Atlantic Canada, where I'm in right now. Sure that you use, you'll also say uh, will be provided an API access token for the request, or the never ever reveal a token. We'll do the we'll do it this way. So that way, even if it does, there is no leak on these access tokens, and user is not able to get access to the header. In fact, I would say this call the token instead of access token. And the discussion to booking service, not encourage user to um, service for any other purpose, allow user to use the service for any other purpose. Uh, I think this is good. I think what we also want to do is we want to. I think yeah, this is good. Let's go from here. So I'm going to create this, and we're going to uh, find out. So essentially, what we want here is when we push this message onto before we push this message onto this, we need to figure out, okay, what are the other things that this step can have. So we actually have the step definition that's here, and we just call the step definition here. So maybe we should have different types of steps, because this is like a simple step, and then we also have a step with functions. So what we'll do is our bot basically has a vec of step definition. So we'll call this the simple step definition. Um, so rename it. Let's call it full step definition. It changes everywhere. And then we'll also call this pub enum step definition. And we'll say there is a simple step definition, and we'll also call it a function um, or with functions. Functions. And there's a vec of the. So we'll also have we'll also make sure that, so for the step definition, uh, we need to have an execute method on it. So that'll be the trait that'll be there. So let's extract this to a trait actually. So copy this. We'll call it an executable step, and we'll call this here. So in Rust, if you have async functions and you want to put this in the trait, you can't do that directly. Gotta put this in a executable trait, sorry, an async trait. So you'll have to get that macro. I'll go add async trait. Have the all the async trait. Do an ls start. So this is good. So we'll have also have a function step definition struct function, and then yeah, we'll have a vec of function definition here. Uh, we'll just call it a backup function. So, and we'll say function. Uh, yeah, we'll go with this. Just let's try to get um, work. So, right. So this is clearly crazy. Give a future of result of um, parsing the statement here. The documentation for theorem. Silly mistake. You've been I think by default it'll be a bin future of. Yeah, I think this should work. Yeah, this works. Um, so it doesn't have new, of course. Once we go to bot, sorry, it's so we'll have to say simple of put this simple step definition. Do a cargo build. I've expected if this and have should work. So that's my head here in real time trying to figure out how what's happening here. Uh, Marco Bell expected simple step definition found step. Ah, okay. So in the refactor, kind of so got that new. This should just be simple. This should just be a vec of step definition, but not simple step definition. Uh, Two. Now, compilation here would have failed because now we're going through each one of these steps. So what we can do is we can impl. So we have this async trait here. So we can basically make sure that uh, one of them also implements this. So we'll have a with function step. Uh, have the functional step definition here, function, and then we have the, okay, got it. So I need to clean this file up. So this is become a big file, like 150 lines of code. Um, Maybe we need to organize this a little better and go from there. So create, um, I'll create a mod steps. Uh, we'll put it at 2 rs. We'll move trait definition into steps or do uh, this file and let's add something onto steps here in what we'll move the executable step definition itself. This we also move it. And so move everything from the simple step definition into that. So we create a step from the simple step definition. Shoot on that. Okay. At the bot. So what this does is it actually creates a step. It um, that means change, but let's one step at a time. We have the spec of step definition, uh, uh, function step definition, that its own place function. Um, so now what the bot does is that it probably extracted it that in haste. See, um, relevant anymore, and uh, then the, so we have the step definition here. Um, abuse. So you can actually pub use uh, declaration so that kind of like re-exports them. So what I'm going to we need to import up. This is crazy. Uh, Role and get chat complete. Um, um, okay, that's because it doesn't execute there. It's fine. So we also need the client. Um, Fine. All right. So there. So now make sure that uh, simple step definition outside. Um, Good. Also step. Oh, this is private, so we don't have to do that. Yes. True, but then be able to. We need to pub this. That also means that we need to expose the async f and execute. This should all be resolved. Yes, that's good. So we have the step definition works, which should work. We have the function step definition, but it's not exported. That good. Um, the step definition. Okay. So good. We step definition, and we do a step definition dot clone. Um, we do a self dot step. So yeah, this is essentially where this is there, because once you now do a self dot steps, um, this is essentially an enum, and we need to be able to have an enum kind of like build itself and then execute it actually. So let's see how that works. So we have so we are doing this in two stages. So we have the simple step definition, which just has the prompt and the user message, um, and then we have the step, which which is the concrete part which the bot knows about, and it builds it. Now we can do this. So the reason why we did not want to have this in here is because it had to create some state which was dependent on the bot, and we thought, okay, we'll use the step um, as sort of like a building block for that, and let that build it. So I mean, that's still a valid strategy that I think that we're going to continue doing that. But somehow we need to make sure we get an executor on the other side, and the executor would have, um, you know, just a sort of like a interface that it can satisfy, and then use that. Or not missing here. So, so for function definition, we're going to let's get this to work here. We have the executable step, which given a string and messages and client, it should give us back this new request. So if we have our step implement that, step definition implement that. So let's see, step definition uh, executable step for this. So let's see what happens. So now, anyway, get these messages and we run this one. So there's this build request and execute, and execute is the one which calls this build request. So that call this request. Should include build request part of the interface? Probably not. We'll keep it simple. We'll have this build request to this, and this creates a that completion. That's the message, and uh, gives us. So this is good, and great. We look at the documentation of the async trait. Let's get out of the this be on the impl as well. Yes. Yes. So of course it doesn't know about self.build request. It's there. Given that it actually requires build request, I think it makes sense to move build request also to rate. Doesn't need to be async though. So hub this hub here because there's implemented rate. Good. So the self definition not found. You don't need self definition. Get the prompt. Um, say there is prompt for is there. Oh, not there for step definition. Self yes. Um, good. The self dot messages is not there, which is true. Self dot messages is not there. So let's look at um, what we need here. So we have this execute method. Um, so that's because we need to um, we wanted to have a history of the step actually, and bot um, gives the history here. So the bot actually does um, creates a step for messages, and it essentially passes the same messages to into the current step. So you don't need uh, we don't need to do this. So let's look at what we need. So we don't need to push the messages, but we can um, the prompt, but also have existing message that we need to push what we are doing self-taught. Oh, this is just returning exist. So we get these messages and then turn off Copilot for a sec here. Once we build this request, I don't get to the messages. So maybe to so it is these messages that we are interested in, the MSGS that we are interested in, so that we can then add the answer to or the completion to this message, right? So um, gives us the build request. Because the thing is, we need to track state here, this point. So let's have, uh, we are doing it for step definition. So let's, uh, our essential chat completion request method. Try to get this return. So this will a spec of to pass in. No, I think it will work. So so you would have an ability to get it down. So which result or not. So user message in to, okay. This is only in the end, right? So we this here is spec of result of. So now this, we get this user message, we have this. So that technically means that we can get back. We would be doing this computation twice. Now this message for passed in here, keep being passed in here, we might as well call these messages here, then pass in the message to this. So we'll say let mute or let equals uh, self dot chat message. We'll do a phone. Now we can do a ps dot push. So this should all work. So now our step definition directly implemented on this. So so this there, but in steps we find this. So we have build request here. This this. So now got.rs should work. Okay, we don't need step definition. So we have the current step here. Um, the current with these messages. So what we want is we want uh, our simple step definition. Sorry, we want our step definition to impel the executable step as well. So we'll do that. The full executable step. So this will be this. Second thoughts, I think we don't need build request. Right? We'll just use build request on step definition. Build request on up here. So we have the this we just say match self. It's full step full of we do the function. Got to do something here. So we do this thing so we can say error not implement. Should be there. So let's. I think um, so this should be there. So I think should this work. So let's compile on this, cargo build on this. So no user message on step definition. What 20. So um, we won't have the step dot user message. So this is because the first step wouldn't have a user, then the step after that would have. First one will have, but the step wouldn't have the user. And we need to pass in when we pass in the current step dot execute, we need to need to basically say whether it's the current step or should it use the given message that's there in the prompt. Um, that's a good point. So what do we do now? So should we just turn it into an option of a string? So if the option is none, then it basically takes it from the current step. Otherwise, it takes it from there. So I think that is still acceptable, whether it's an option of a string. But I don't want to change. Uh, so there's only two ways, right? Either we expose the user message to our enum and get that. Doesn't seem like a bad idea. Let's do that. So uh, pub uh, call it a string match self. So, we simply to a self-taught user message. Pub. Uh, is anything else for now? We'll just for now. It's still going to return a string. Yeah. This then we'll go to bot. Um, call it. It says cannot find the value of current step of scope. Just be step dot execute. Step definition. We are setting up. Oh, it's only doing it for self. That's interesting. Good question. Does this need to be unmute? It doesn't need to, because you only need to ever read the values from. So step definition. So we shouldn't need this to be mutable. Fine. Fine as well. So this is good. Quotes as now this is doing this. Bad, but here still says it's a step def. So we have a vec of step definition. Steps. Mainly hints are. Yeah, this is. I'm just. It says some items can only be used if the trait is included and hope. Ah, so okay, that is probably the reason. So it does find it, but probably has been included here. So let's that trait in. Let's see if the LSP gives a hint. Clearly wrong to trait def. Then pub the trait. Now this should yes. Finds it. Thank you. Codes. Good. We got this. Uh, steps. Step definition. Oh, we do need use pub use. Go to bot. Pub use that. Cannot move out as the user. Uh, dot clone. There's a clone. Constructed FTO. Not there. Okay. This is all bunch of warnings on function step. I'm ignore that. This is good. So essentially what this means is our cargo run should just work. Cargo build. Good. Okay, we are essentially back to the same state that we are. It's just that uh, we now have our code refactored a little bit so that it kind of supports both, you know, calling it with function definition and simple definition. We haven't actually done uh, function calling yet, but yeah, it took a couple of hours to get to this state. Sorry about that. Let us see. It takes a while for this stuff. So, and this is something that I guess we need to consider when we are integrating with these APIs is the performance of the ChatGPT API itself. We are using the Turbo 3.5 model, but then has to wait for its tokens to complete and generations to complete, and so on. So we'll look at shouldn't be taking so much. Maybe I should have started this fast log. But anyway, so while this is completing, I mean, there's nothing uh, obviously that's broken here. If it's broken here, we'll know soon enough. Let's think about how we're going to look at functions. Now, functions would have a name, will have a description, arguments. We'll call it string. You'll have a vector function. You have so you'll have the prompt, and you'll also have the user message that's there. I think prompt is essentially going to be our system, just as before. Our user message would essentially be whatever the user gives us, because most likely the if you're using function definition, that's going to be step in your this thing. Could have, not necessary that the only one, but in the chain, I most likely it's the first one. Go from there. So let's start building this out. So before that, this still going. Did I kill it? Not to kill it. Or maybe I should. Uh, do doing an await here, and we are doing an OK of messages in main.rs. Printing those messages. Yes, we are printing those messages. All be good. So still waiting, I guess. Oh, I think it did get the first prompt in. Uh, yeah, it got the first, I mean, the answer to the first prompt. Second prompt that it's parsing. Yeah, no, it's still not answered. So yeah, now it is finished. So let's look at uh, it. Oh, it doesn't give it back in JSON. Yeah, I didn't give it back in JSON. I guess this is one of those things that we need to figure out how that works. I mean, if it can always coax it to give it in JSON. But yeah, anyway, so we are digressing. So let's come back to this. So now we have our prompt that is written, uh, called uh, menu bot, and we have to describe our endpoints. We have to write code for our endpoints and also describe our endpoints. So let's look at that. So have So we have an API to get bookings, or let's say we'll keep it simple, get locations. Uh, so let's see what is the function calling going to look like. So this the uh, JSON function, not like the parameters. I get the JSON. Type object property. For the city, and it has parameters, type object, and then we have properties. You have the location and type. Okay. The name of the param is that as one of the basic types, but string. But this most likely is going to be an enum, a string, or um, a number or things like that. So then have, oh yeah, that's just parameters. Then we have type and type and description. And those are, I model it as a B tree map instead of vector function params. So I think I'm going to keep this way. I think So drawing a blank here. I need a coffee. I'm gonna take a quick break, guys, and then I'm gonna be back. I'll probably end the stream for now. I'll probably continue this follow-up stream this where we are actually going to make this call. But yeah, what we did today was essentially refactor the step definition into its own uh, format and then kind of go from there.